Good morning, everyone. Welcome. My mission has always been to organize the world's information and make it universally accessible and useful. But today, as we stand on the frontier of the generative AI revolution, we face a critical challenge. How do we make state of the art intelligence available to the billions of people living beyond the reach of high speed internet or behind financial paywalls? Today, I'm incredibly proud to present Chhanda, a production hardened 100% offline local AI gateway that transforms any standard smartphone into a multi client offline server node powered by Google's Gemma 4 through the native LiteRTLM runtime. Chanda bridges the digital divide by delivering zero cost, zero latency, and zero cloud AI accessibility to the last mile. The platform is solo developed by myself over 3 weeks, written over 14K lines of highly optimized Kotlin code, and is named in honor of my beloved mother, Chhanda Chakraborty. In Bengali, Chhanda represents the beautiful rhythm of poetry and meter, just as raw syllables structured into words. Chhanda structures raw local tokens into flowing offline human intelligence. Let's look at how we built it. To understand why Chanda is necessary, we must look at the realities of the global south. Over 600 million people in rural India and Bangladesh live without consistent broadband access. And for these students, doctors, and small businesses, the cloud simply does not exist. Furthermore, in communities where mobile internet is metered, paying $20 a month for a cloud AI subscription is an economic impossibility. Finally, in high stakes fields like rural medicine, sending sensitive patient symptoms, or village documents to distant cloud servers creates massive privacy vulnerabilities. Chanda's vision is simple: zero cloud, zero cost, absolutely privacy. By executing quantized Gemma 4 widths natively on device, we eliminate cloud dependency entirely. We didn't stop at building a single user app. We designed Chanda as a gateway. A single 15,000 rupees Android smartphone running Chanda acts as a local Wi-Fi hotspot, providing the state-of-the-art AI access to the entire classroom, clinic, or municipal office, completely offline. Let me show you how this collaborative LAN architecture works. At the heart of Chanda is an embedded asynchronous KTOR CIO HTTP server, written entirely using Kotlin coroutines. The host phone registers a standard OpenAI compatible API endpoint over the local Wi-Fi network. For students or workers, there is absolutely zero app installation required. They simply connect to the phone's hotspot, scan the generated QR code, and open a beautiful responsive web portal on any browser, as shown on the right. For software developers and students learning to write code in remote regions, Chanda acts as a local alternative GitHub Copilot. They can configure the VS Code continue extension to point directly to port 48 on the local phone, enabling fully offline coding companion. To ensure gateway remains 100% crash free under load, we have implemented a custom leaky bucket rate limiter per IP and capped active inference concurrency to two simultaneous tasks using native semaphores. The result: industrial grade server stability running entirely in a pocket. Gemma is incredibly capable of out of the box. But local users need to ground the model in their own domain data. Chanda features a fully local RAG pipeline that supports offline ingestion of PDFs, Word documents, Excel, spreadsheets, CSVs, and even images on the device using MLKit OCR. To make this visible on standard Android phones, we have introduced two key computer science innovations. First, we have implemented a int8 embedding quantization. Instead of storing the high dimensional embeddings as raw 32-bit floats, we compress them into a signed 8-bit integers. This delivers a massive 75% reduction in RAM and disk footprint with zero noticeable loss in retrieval accuracy. Second, standard search engines rely on big O of n log n library array sorting. On a phone, this is a thermal death sentence. We engineered a custom mini heap top K search algorithm in Kotlin. This reduces retrieval search complexity to big O of n log k, providing 3 times faster local RAG under sub-milliseconds compute cost. We also added pronoun aware context expansion. Let the user ask natural follow-up questions without losing the semantic context. Security is not an afterthought when serving AI over a local network because Chanda is built for real world deployments in clinics, schools, municipal offices. It implements an enterprise grade multi layered security model. At the input layer, we protect the local Gemma engine from the prompt manipulation using a 3-layer prompt injection shield. It intercepts all the user queries and validates them against explicit word blacklist and heuristic regular expressions. It then wraps inputs and fetch the context in logical structured delimiters to prevent context escape. At the storage layer, any sensitive data, including the Huggies Face download tokens, is protected in the device physical trusted execution environment (TEE) using the Android key store system. We have also integrated an automatic PII re-education system that sanitizes emails, names, phone numbers locally before they touch the inference engine and wrap the entire configuration dashboard behind a native biometric authentication. It's a zero trust architecture running completely on edge hardware. An enterprise grade application must be accompanied by an equally elite premium user experience. We designed Chanda following Google's highest material tree guidelines, removing redundant buttons to present a zero clutter layout. You might be, having a question that why every time I am asking, like, why we? So here we means me and Gemini 3 Flash. I'm using anti-gravity for the coding part with and using Gemini 3 Flash as a coding assistant. So let's go to the next part. First, for developers and network administrators, we build a beautiful interactive rolling log terminal console directly inside the app, letting you debug client request packets in real time. Second, Chanda supports hot swapping local modules in under 2 seconds. releasing binary allocation and invoking JVM garbage collection gracefully without requiring a manual app reboot. Third, we have created a dynamic local TTS script parser. When the local Gemma model generates bilingual answers, the system reads the character ranges and if catches Devangari or Bengali characters, it immediately swaps the active text to speech engine local on the fly. To make the spoken output sound natural and human like, engineer an acoustic citation scrubbing regular expression parser. It automatically strips bracked references and markdown links prior to synthesis, ensuring a warm, flowing speech experience. When chatting with Chanda, the user is provided with immediate, high fidelity visual feedback. As you can see in the screenshot on the right, the streaming conversion bubbles and are accompanied by real time micro performance indicators. Users see the exact tokens per second generation speed, total token counts, and the sub-millisecond RAG latency. The voice assistant works in a high robust single shot pattern, implementing a 500 millisecond safety lock that prevents echoing loops when the speaker terminates. To protect the host hardware under the intense workload, Chhanda includes a thermal aware context scaling system. It actively tracks Android's device hardware temperature. If the phone starts to heat up under heavy load, Chhanda dynamically shrinks the Gemma context window, keeping the device cool and preventing memory or GNI crashes. Furthermore, all telemetry polling loops are strictly lifecycle aware, suspending automatically the instantly the app and minimizing to save 12% in idle battery life. Let's place Chanda in the competitive landscape. When you look at the official AI Google, like the Edge Gallery developer samples, they are great starting points, but they are limited to single user local chats and lacks any server capabilities, RAG pipelines, or security layers. Commercial tools like ChatGPT Mobile are highly capable but are completely dependent on expensive internet connections, require a $20 a month subscription, and send private customer data to remote servers. Chanda AI Gateway stands alone. It combines the 100% offline, free forever benefits of running Google's open web Gemma models with a full suite of enterprise features, multi-client server hosting, int8 quantized local rack, dynamic thermal aware context scale, multilingual speech, script swapping, and hardware secure credential isolation. It's not just an app, it's a full-fledged computing utility. Beyond the raw code, the ultimate metric of Chanda's success is its human impact. In education, Chanda changes the game. A single mid-range Android device running this software can become the offline AI tutor and library for an entire school. Teacher can index complete curriculums and student connect with via low-cost devices to learn in their native languages. In healthcare, Chanda enables absolute privacy. Community health workers in remote location can query complex clinical guidelines and can process sensitive diagnostics notes locally, knowing that not a single byte of patient data ever leaves the physical device. In digital equity, Chanda represents a democratic. shift. It provides underdeserved offline communities and the exact same stake of the art AI capabilities that are normally locked behind broadband connections and expensive subscriptions. This is what we mean by Gemma for good. In conclusion, Chanda is a testament to what is possible when we push boundaries of edge computing. With 14,500 plus lines of production hardened Kotlin, a zero trust local security model, and a high performance vector database. And the proofs that world class AI reasoning can be delivered to every single corner of the globe, completely offline. It represents a future where intelligence is a public utility, not a cloud luxury. By running Google's Gemma 4 native on device, we have unlocked a private, secure, and collaborative AI ecosystem that fits inside a pocket. I want to thank Google AI Edge and Gemma for Good Hackathon organizers for providing the incredible models and tools that made this solo project possible. The entire code base is open source and available on GitHub for the global community to adapt, build, and deploy. Let us build a more inclusive, resilient, and intelligent world together. Thank you very much.